You've probably seen those sensationalist headlines on TV or the internet like, "Yellow melon prevents dengue," or "Exercise doesn't help you lose weight, it only maintains it." The problem with these news stories is that they often rely on isolated studies or even misinterpretations of science. As we will see, the reality is much more complex. Hi, this is Carol, and you're watching No More Yo-Yo, the channel where the truth about healthy weight loss comes to light, no holds barred. Today, we're going to discuss a controversial topic. Is obesity genetic? The New England Journal of Medicine, one of the most respected scientific journals in the world, published an article with researchers from Harvard University in the United States and the Broad Institute in Cambridge, England. They investigated how a specific genetic variation could influence the development of adipose cells, the ones that store fat in our bodies. And of course, the media jumped on it with headlines like, "Obesity is genetic, says study, and your struggle with weight could be in your genes." But is it really that simple? Let's get to the facts. Science doesn't work with a single discovery that changes everything overnight. It requires a consistent body of evidence. Genetics can indeed influence the predisposition to obesity, but it is not a life sentence. Environmental, behavioral, and metabolic factors also play a huge role. Want a practical example? Think of Chris Hemsworth, the guy who plays Thor. His genetics help a lot, but do you think he looks that way just because of his genes? Without intense training and a controlled diet, he wouldn't be the superhero we know. The same goes for obesity. Even if you have a genetic predisposition, it doesn't mean you're doomed to be obese. Dietary choices, physical exercise, and a healthy lifestyle make all the difference. It's like playing poker. You don't choose the cards you're dealt, but you decide how to play them. So, the next time you see a news story saying that obesity is purely genetic, remember that the truth is more complex. We can't just blame genes and ignore the choices we make every day. Want more unfiltered truths about weight loss and health? Subscribe to the channel and leave a like. Here at No More Yo-Yo, we simplify what others complicate. Let's get straight to the point. To understand this news well first, you need to understand that all the cells in our body, in your arm, brain, heart, have the same genetic information, the same DNA. But if they all have the same DNA, how can they be different? And not just different, but perform different functions. The key to this lies in how the DNA is activated. The DNA in heart cells is activated one way, while in the brain, it's activated another way. This process depends on the environment the cell is in and how this environment interacts with it. Skin cells have the same genes as brain cells, but some genes are activated in the brain and others only in the skin. This means that despite all cells having the same genetic information, gene activation varies according to the environment and location of the cell. Moreover, some genes can activate other genes, and a mutation in this initial gene can deactivate both. This study of how genes are activated and which genes are active in specific situations is called epigenetics. Don't forget this name, as it is crucial. Going back to the obesity gene mentioned in the news, researchers have long tried to identify the genetic factor related to obesity. You might have noticed that obese parents tend to have obese children, but this is not an absolute rule. Scientists investigate this genetic factor through genetic analyses, comparing the genes of obese people with those of people of normal weight. They look for genetic variations that might be associated with increased production of some protein, which could be a contributing factor to obesity. If this genetic variation is present only in obese people and not in people of normal weight, it could be an indication of a genetic factor linked to obesity. This is how science advances, unraveling the mysteries surrounding our genes and how they influence our bodies and health. Several obesity genes have already been discovered and can be passed from parent to child. When a gene is said to be related to a disease, it means that this gene is present in both normal people and sick people. But there is a variation in the sick people that usually leads to the disease. This gene can activate other genes, create a defective protein, or interfere with the creation of a protein. Of course, environmental factors such as diet, lifestyle, and diseases like diabetes and thyroid dysfunction can influence how the body handles excess weight. That's why obese parents don't always have obese children. The obesity gene mentioned in the news is an old acquaintance of science called FTO. Researchers found a variation of this gene in obese people. This gene was already known to be activated in the precursors of cells that form adipocytes, the cells that store fat in our body. There are two types of adipocytes: brown ones, which store fat and can burn it to produce energy, and white ones, which store fat and produce very little energy. No need to say, right? The problem lies with white adipocytes, which are related to obesity. So, if you've ever wondered why some people gain weight more easily than others, the answer might lie in this gene. But don't forget, genetics is not an immutable destiny. Lifestyle, diet, and exercise still play a crucial role in your health. Science is here to give us tools, but the choice of how to use them is ours. Let me see if I understand. The precursors can give rise to both brown fat cells, which burn fat, and white fat cells, which don't. Exactly. But the problem is that the variation of this FTO gene, present in most obese people, directs the formation of white fat cells, which don't burn fat. How do researchers know this? They discovered that when the FTO gene variation was corrected using molecular biology techniques, the cells started becoming brown fat cells. So they studied further and they discovered that the FTO gene is actually a gene that activates other genes. This variation of FTO is much more related to two genes called IRX3 and IRX5. These two genes are the ones that transform cells into white fat cells. If they are highly activated, they will turn the cells into white adipocytes. If they are less activated, they will form more brown cells. But why does someone who isn't into science need to know this? This is a very interesting question and is the motivation for making this type of video on the channel. Knowing that the variation of the FTO gene directs the formation of white fat cells instead of brown ones explains why some people have more difficulty losing weight. This information isn't just scientific curiosity. It helps us understand that the struggle with weight is not just a matter of willpower. There are real genetic factors that influence how our bodies store and burn fat. This understanding can change how we approach weight loss. If you know your body has a genetic tendency to form more white fat cells, you can focus on specific strategies to combat this, whether through diet, physical exercise, or even in the future, treatments that might influence these genes. So yes, it is worth knowing and understanding these mechanisms. And that's why we make videos like this, to bring to light information that can make a difference in your pursuit of healthy weight loss. If you enjoyed this content and want to know more about health, don't forget to subscribe to the channel. I know this knowledge can seem difficult for most people who aren't connected to science daily, but it is very important for one reason. We cannot lack critical thinking, not only in politics, but also in science. We've seen news talking about an obesity gene, but now you know it's not just one gene controlling obesity. There are also environmental factors. Just from that, the news is already somewhat sensationalist by talking about an obesity gene. With this, I want to start a small discussion. Isn't it time to start genetic mapping at births? For example, you would have your child, he's just born, and then you'd do a genetic mapping and discover that he has a gene that predisposes him to obesity. From there, you could educate your child to have a good diet and exercise regularly, perhaps focusing on exercises that help avoid weight gain. Sure, exercising and maintaining a good diet is something everyone should do, but this would justify genetic mapping. Imagine the difference this could make. Knowing early on if a person has a genetic predisposition to obesity would allow preventive measures to be taken from childhood. And we're not talking about restrictive diets or strenuous exercises, but about a healthy lifestyle adapted to each person's genetic needs. But here comes the ethical question. To what extent should we use this information? Could this lead to increased discrimination or stigmatization? After all, knowing that someone has a gene related to obesity could influence how that person is treated by society. On the other hand, not using this information would be ignoring a powerful tool that could help prevent health problems in the future. So, are we ready for this new era of genetic mapping? It's worth considering the benefits and challenges. What do you think? Leave your comment, and let's discuss more about this fascinating and controversial topic. Imagine specific exercises that would prevent your child from becoming obese in the future and avoiding heart problems, for example. And if you had the opportunity to observe your child during development and discover that he is predisposed to have a fatal disease, wouldn't you invest in preventing that disease before your child is born? It's just a question, not my opinion, but I'd like you to think about it. Some countries already do genetic mapping for certain diseases, such as cystic fibrosis. This disease is very severe, affects children's lungs, and causes them to produce either too much mucus or almost none. This leads to respiratory problems, infections, and often results in the child's early death before the age of 10. They suffer greatly. Why not use this technology for other conditions, such as obesity? If we knew from an early age that a child has a genetic predisposition to gain weight, we could implement preventive measures from the start, This could include a balanced diet, specific exercises, and more rigorous medical monitoring. We could prevent obesity, heart disease, and other complications associated with excess weight. Of course, the idea of genetically mapping all children at birth raises many ethical and practical questions. Who would have access to this information? How can we ensure it's used for the child's well-being and not to discriminate against them? And how do we handle the psychological impact of knowing one has a genetic predisposition to certain conditions? But think about the potential, the ability to prevent diseases before they even manifest. We are already doing this with cystic fibrosis, so why not expand this practice? After all, prevention is always better than treatment. Let's continue this discussion in the comments. What do you think about genetic mapping in newborns? Would it be an effective preventive measure or a risky step? Leave your opinion. Is it right to perform genetic mapping and perhaps discover a disease before it develops? I really want to know your opinion in the comments, and speaking of important discoveries, I have a personal revelation and a special tip for you. As someone who has long struggled with weight and knows the yo-yo effect all too well, I understand how challenging it is to find effective and healthy weight loss solutions. That's why I want to share with you Live Pure, the supplement that is redefining my weight loss experience. With its natural ingredients and unique liver purification formula, Live Pure has been an incredible ally in accelerating fat burning in a way that respects my body and health. Feel amazing, both inside and out, and give a new boost to your weight loss journey. And the best part, if Live Pure doesn't meet your expectations, there is a 100% money-back guarantee for 60 days. This means you can try Live Pure risk-free. Click the link in the first pinned comment and start transforming your body and health today. Because being chic also means taking care of yourself. So are you ready to join me in this transformation? Let's do this together. If you enjoyed the video, don't forget to leave a thumbs up, subscribe to the channel, and hit the bell so you don't miss any content. Speaking of content, you won't want to miss the next video. So get ready to watch Smart Food Swaps for Weight Loss: How to Lose Weight in a Healthy Way. All the best always. See you next time.